Hello students. Now as we are doing some practice work from R.S. Agarwal book, and yesterday we started chapter 5 exponent and power, and I explained some specific sum from exercise 5a yesterday. So today also we'll continue with the same exercise, that is exercise 5a. So today also I've come up with 4 questions. So we'll start with sum number 1 of question number 10. Okay, so what is sum number 1 of question number 10? It is 1 by 4 minus 1 by 4 to the power 2. Then we'll give the curly bracket. Then we have power minus 2. And then again we have one square bracket. And that will be to the power minus 1. You see, we have three powers. Now, as we have learned in exponents that a to the power n to the power m. So this is the power law. So what we are supposed to do with this law? So we used to multiply the powers, isn't it? That means n into m. But what if we have another power? What if we have another power? Suppose like this, p. So in this case also we will do the same thing. That is, we will multiply all the powers together. That is like this. Okay, so same thing will apply on this sum also. So we have a base that is minus 1 by 4, isn't it, students? So we'll write the base minus 1 by 4 and we will multiply all the powers. That is 2 into minus 2 into minus 1. So the result of the powers, so what will be the product of the powers? That would be 4 only. Because 2 into minus 2 is minus 4. Minus 4 into minus 1 is plus 4. So now we'll simplify this part. Now how many times we have to multiply the base? What is the power given? 4 times we have to multiply. That is 1 by 4 into minus 1 by 4 into minus 1 by 4 into minus 1 by 4. So now the first thing that what you have to do, you have to see that how many minus sign are there. So count it. 1, 2, 3, 4. 4 means even number. 4 is an even number. So when number of minus sign is even, your answer will be always in the positive form. So no need of giving any sign. So now multiply all the numerators. 1 into 1 into 1 into 1 is 1. 4 into 4 into 4 into 4 is 256. So this is your required answer, students. Okay. Now the next sum that I have selected is sum number 12. Sum number 12, students. Yes, now what is there in sum number 12? By what number should 3 to the power minus 3 be multiplied to obtain 4? Now it is in this form, students. See, 3 to the power minus 3 is there. Now you have to find out this number. That means, what is the number that you have to multiply with 3 to the power minus 3 so that your answer should come 4. Now, in the junior class, especially during the mental math, when you're supposed to solve the mental math sum, see, if I give you this type sum, 2 into what? 2 into what is 12. So in this case, what you were supposed to do? So we were supposed to do is that 12, we used to divide 12 with this number. Why? To get this particular required number, isn't it? That means 12 divide. If we divide this 12 by 2, then what we get the answer as 6. So if you put this answer here, you see it satisfies the equation. That is 6 into 2 is 12. So same logic we have to use it here also. Okay, the same logic we'll use it here. So before that, you need to write, therefore the required number. Therefore the required number would be what? That is 4 divided by 3 to the power minus 3. Okay, now this 3 to the power minus 3 can be written as 3 by 1. As we know that 3 is carrying 1 as a denominator. Now this time we will write it down. Minus 3. Now what did I say yesterday? That if you see any negative power, then the first thing is to make this power positive. And how to make it positive? You have to reciprocal the base. So what is the reciprocal form of 3 by 1? I hope all of you know this. It would be 1 by 3, and this way, and this is how you have made the power positive. Now, before we solve further, what is the first thing that you have to solve? You have to solve this one. That means you have to simplify this form first. So how many times you have to multiply the base? 3 times. So first do that. Give one bracket. 1 by 3, 1 by 3, 1 by 3. Okay, now multiply it. So you get the required answer as 1 into 1 into 1 is 1. 3 into 3 into 3 is 27. Now finally we'll change this sign to multiplication sign. So when we do that, the right hand side of the fraction get again reciprocal. That is 27 by 1. And your required answer would be 108 by 1. So we do not write 108 by 1. You can just straight away write only 108. So this is a solution of question number 12, students. Very, very important. This type of sums will carry 3 marks. Okay. Now let's do the next sum, that is question number 14, students. 14. Now this is question number 14. We have LHS. Now this part is LHS and this part is RHS. Fine. Now in this type of question, the first thing that you will see is that on the left hand side all the base are same. And the same thing you will do it with the right hand side. The base is same. That is, you have to see that whether both the side the base are same or not. So in this case you see the base are what? 3 by 5, 3 by 5, 3 by 5. So in both the side the base are similar. Now what is the next step that you have to do? You have to solve the RHS part. Fine. So if you consider this 3 by 5 as base, and if these two bases are carrying multiplication sign in between, so what we have to do with the powers? So what we have learned in exponents, that if any base is carrying n, if another base that is similar to a is carrying m as a power, so what we do with the power? We add the power, isn't it? This is what we have learned. So the same thing we'll do it towards left hand side. So what is a base? What is a similar base? Common base is 3 by 5. So we'll write 3 by 5 to the power. We'll add the powers. 3 plus, but this power is having minus sign, so we'll put it inside the bracket like this. Okay, and the right hand side will write it as intact, because we have nothing we have to do with right hand side. We cannot do anything. So we'll just write it as intact. Now solve this one. 3 plus minus 6. 3 plus minus 6 is what? 3 minus 6, and that would be, the answer would be what? Minus 3. So we'll write 3 by 5 to the power minus 3 equals to 3 by 5 to the power 2x plus 1. Okay. Now when you see that you have reached such a position that in both the side you have a singular base, that is on the right hand side also you have one base, on the right hand side also one base, and if both the base are similar, now in this case what you have to do, you have to just compare the powers. So what you have to write? Comparing the powers. So what you have to write? Minus 3 equals to 2x plus 1. Okay, what is the next step? You know that to get the value of x, we have to transpose this plus 1 towards right hand side. Towards left hand side. So it will look like minus 3 and plus 1. I hope it is plus 1. Sorry, I've written the question wrong, students. It would be minus 1. Minus 1. Sorry. It would be minus 1. Minus 1, so here would be also minus 1. So when you transpose minus 1 towards left hand side, it will become positive, and that would be equals to 2x. Now what is the next step? Minus 3 plus 1 is minus 2 to the equals to 2x, and finally we have to bring this positive 2 towards left hand side, so it will look like minus 2 by 2 equals to x, and your final answer would be minus 1. Okay, so this type of sum will again carry 3 marks, students. Very, very important sums. Okay, now let's do the last sum for today. That is sum number 15. Now this is sum number 15, students. Now in this type of questions, we'll target all the composite number base. So base which are composite number. Fine. Now you see this number The first base is 3. So 3 is a prime number, so nothing to do about it. So just target all the composite numbers. This is composite number, 10 is composite number, 25 is composite number, 6 is composite number, and this 3 and 5 are what? These are prime numbers. So we'll do nothing with the prime numbers, but we will try to expand all those composite numbers. Okay, now see, these are my targets. Now what to do with all those composite numbers then? So we'll keep this part as intact, that is 3 to the power 5 into, now how to write 10? So in place of 10, can we write this 2 into 5? Isn't it? If we do the prime factorization of 10, so we'll get this one 2 into 5. That would be to the power 10. Now 25. If we do the prime factorization of 25, we'll get this 5 into 5. Isn't it? Now divided by 5. As I said, we'll do nothing with the base which is in the form of prime number. Now 6 can be written as, if you prime factorize number 6, we'll get 2 into 3, that would be to the power 5, isn't it? So now we have simplified all the composite numbers. Now we have to open the bracket. So the next step is 3 to the power 5. How to open the bracket? That means this 2 and 5 are inside the bracket, and both these two numbers are having 10 as a common power. So if I'm opening the bracket, so I have to give 10 power to 2 also, and with to 5 also. Okay, this is how you have to open the bracket. 5 into 5 can be written as 5 square, 5 to the power 7, and 2 into 3. Again, we'll apply the same rule, that is 2 will carry 5 as a power, and 3 will also carry 5 as a power. Okay, now just see if any terms are similar or not. Yes, there are some similar terms. That is 3 to the power 5, 3 to the power 5. So cancel this. 2 to the power, sorry, we have 5 here. Why I'm doing some mistakes here? So we will write 5 here. Again, we will write 5 here. We will write 5 here. Okay. So 2 to the power 5 and 2 to the power 5 are similar. So we'll cancel this. Okay. So we are left out with 5 to the power 5 into 5 square. In the denominator we have only 5 to the power 7. So we'll write it down. So 5 to the power 5 into 5 square and 5 to the power 7. Now first of all we'll solve the denominator. Now in denominator we have two similar base with multiplication sign in between. So we have to add the powers. So 5 to the power 5 plus 2 by 5 to the power 7. So 5 plus 2 would give us 5 to the power 7, 5 to the power 7. Now you see the numerator and the denominator are very similar to each other. So again we'll cancel this. So your required answer will be what? Equals to 1. Okay, so this is a solution of question number 15, students. That's it for today's session. Thank you so much. God bless you all and stay blessed.